Hello everyone, and thanks so much for joining our session today covering Redis on 5G Edge. My name is Robert Belson, and I'm super excited to be here at virtual RedisConf to share our experiences with building on Redis Enterprise and what 5G and mobile edge computing together means for you as you think about building and architecting next generation applications. So over the course of the session, we hope to cover a number of things, most importantly providing an overview of the fundamentals of mobile edge computing and how you can leverage and stand up your first Redis Enterprise cluster at the edge to enable that ultra low latency caching experience within the fabric of your existing architecture. And as we think about the theme of RedisConf this year, I really couldn't think of a better application of rediscovering the power of real-time data than taking an existing architecture and applying it in the context of a 5G Edge world. So with that in mind, let's start with a bit of background. So in my role in leading developer relations for our mobile edge computing portfolio, I've worked with a number of customers who've all experienced the same fundamental problem. As engineering teams, we're trying to optimize user experiences and delivering on this promise of real-time data, but we want to do so without having to re-platform our existing architecture. And so while today we might mask application latency with animation, what if there was a better way? And this exactly was the problem statement that motivated us to team up with AWS to co-develop 5G Edge. And so 5G Edge is all about bringing popular compute and storage services to the edge of our mobile network, to the edge of our 4G and 5G nationwide network, and doing so within the fabric of your existing cloud environments, or VPC as an example. And this is exactly what AWS Wavelength offers today. Using Wavelength Zones, developers can simply extend their VPC to include subnets in Wavelength Zones. So as an example, instead of serving your customers across the Eastern Seaboard, you can now do so from Wavelength Zones in Boston, DC, Atlanta, and Miami. And so in other words, as we intuitively think about latency being a function of proximity, so physical distance to cloud resources, 5G Edge finally presents developers with more choices than ever before for where to deploy their applications, and in turn allows us to drive lower latency and more performant user experiences. And so now the question we have, of course, is so where does Redis Enterprise come in? And so let's take an e-commerce application exactly as you're seeing here. Let's just take a recent study as an example. Akamai had recently suggested that a sheer 100 milliseconds in website load time can affect conversion rates by almost 7%. And we also know that checkout speed, which is so primarily dependent on end-to-end latency of compute operations themselves, remains such an important decision-making factor whether a customer will actually return to a given site. And as we think about transactional workloads in nature requiring not just compute for things like fraud detection or payment processing, you of course also need in-memory data stores for user profiles, shopping carts, and inventory search. With that in mind, it was so clear to us at Verizon that Redis Enterprise was the natural choice. And so to understand exactly what we built, let's start with the fundamentals here of what exactly 5G Edge is. Simply put, many of you might be familiar with 5G networks and that step change or exponential improvements that you're going to see as you think about improvements in latency, bandwidth, device density, etc. Now let's talk about if you overlay mobile edge computing on top of that, what are you actually provided as a developer? And so the first thing we want to highlight is that Verizon 5G Edge is not a CDN. Simply put, CDN is all about distributing those often static storage assets to a wide variety of geographies. This really is about decentralizing and distributing compute more so than storage assets to the edge of the network. And more importantly, this is one of the most important points, that as you think about a mobile environment, even if some sort of data center or CDN is geographically closer to an end user, topologically speaking, as you think about a mobile network, it's all about these different radios converging to that single access point that anchors to an IP address. So what that really means is that to get the lowest latency, you want to be as close to the edge of the mobile network It's not just about geographic distance. Rather, these mobile edge computing nodes, those computing resources that are within the edge of the network, are thus the closest topologically to that end user, and thus the lowest latency solution in a mobile environment. And this is such an important point. As we now think about what 5G Edge actually is in the context of AWS Wavelength, 5G Edge is our portfolio of mobile edge computing solutions, of which AWS Wavelength is our public flavor. And so as you think about what this actually provides, it's really just a logical extension of the availability zone concept. So today, in AWS as an example, you have a series of regions, each of which have a series of availability zones. Think about this as your logical or atomic data center unit. Now, instead of having maybe 6 choices in the US East 1 or Northern Virginia region, you now have so many more choices of where that availability zone can actually lie. So now, instead of just Northern Virginia, you can have Boston, Atlanta, Miami, Washington, D.C., just to give you a few examples here, all of which have EC2, ECS, EKS, and EBS supported. So that means all of your core compute services as you think about standing up virtual machines, containerized infrastructure, block storage, and then the full host of services available to you in the parent region. This is essentially everything you need to build your application, but topologically closer to the user than ever before. And by having those key services here today, the act of an edge migration is barely a lift and shift. It's really all about, especially if your infrastructure is containerized, you already have your container registry. Just extend your Kubernetes infrastructure, as an example, to the network edge and deploy your services accordingly. So as we think about our reference architecture, what we actually built, we had 2 clusters because we really wanted to figure out how much more performant is Redis Enterprise at the edge versus Redis Enterprise today in what we call the parent region. So as we walk through exactly what we did here, what you're going to see is we have a single VPC that encapsulates the entire environment in both the northern, actually in this case, not Northern Virginia, we used US West 2, so the Oregon region, an availability zone in Oregon, but then an availability zone in the Denver Wavelength Zone. The unique part, of course, of wavelength is that because you have this notion or topology of availability zones within a region, even if this availability zone is in, geographically speaking, a different metro area, it can actually be connected within a single VPC, all talking, of course, via private IP addresses, and doing so potentially from hundreds of miles away. So this is extremely powerful. So what we did, again, for the experiment and our setup, 2 different clusters having nothing to do with one another. So for each availability zone, let's start with the Oregon US West 2A as an example. We stood up 3 R5 2x large instances, and this is exactly what you might do today in AWS. We ran the Red Hat Enterprise Linux 7 AMI for each of those instances. And then we used the management UI for Redis Enterprise to help configure the cluster. For each of these 3 instances, all join that cluster that we created, and then do the exact same thing in the carrier data center, or wavelength zone, as we call it. And so once we configured these 2 clusters, what we then did was we said, okay, what do we actually want to measure? We figured the simplest thing we can do to really baseline the improvement is send the smallest possible payload, so the equivalent of like set foo bar, or in this case we set key 1 to 123, and then get that resource and timestamp that operation of that write followed by a read. Then delete the key and run that over and over and over again to get a baseline of how fast is it today in an availability zone, and then how much faster is it tomorrow with a wavelength zone. And we ran this about 1,000 times total per availability zone to conduct that benchmark. And so the question is, what do we see and what do we find? Short answer, wavelength outperformed our parent region by a significant margin. You look at the round trip time, again, of that write followed by a read, we saw well over 45% improvement, which is incredibly powerful. And this, of course, is because that Redis cluster, that Redis Enterprise cluster, was that much closer to the end user. So instead of having to egress or leave the mobile network where we can control performance in QoS, you egress the mobile network, our mobile network, into the internet, and then essentially live by the notion that an internet was designed as a best effort service. So you're going to get less reliability, more packet loss, more jitter, and that's why you see that 45.4%. But what's also important to call out is, again, what we did from a benchmarking perspective was the simplest possible operation you could do. Now, if instead of you're setting a simple key to a 1, 2, 3 to this tiny payload, let's change that to a more complicated hash or sorted set or geospatial or even a transaction. Now let's say what you're trying to do is between your multi and exec commands, you have 10 commands, each of which have material payload. The network effects literally start to add up of that performance improvement you get for each invocation or remote invocation and query of your Redis database. As a result, the more payload, the more performance benefit you're going to see. And this is what got us excited. And I'll mention a huge thank you to Andre and team, our solution architects at Redis Enterprise, who helped us with these experiments here, because we started to think about applications. Again, the theme of Virtual RedisConf this year is all about rediscovering the power of real-time data. We think there's a tremendous opportunity with Redis Enterprise at the edge, not just because you can stand up a standalone cluster and see those performance benefits as a standalone unit, but if you start to think about active-active databases, there's such tremendous opportunity for high-speed transactions, but also the replication associated with it. And so for those of you that are less familiar with active-active databases, they're all about these geo-distributed topologies or conflict-free replicated data types, also known as CRDTs, that offer local latency on read and write operations, but also seamless conflict resolution for various complex data types. And so what this could allow you to do now is, instead of having that single cache only from Northern Virginia serving the entire eastern seaboard, look at this map you see right here. You have so many more different choices for how the replication and deployment takes place. And so to recap here, we believe that mobile edge computing through Verizon 5G Edge and AWS Wavelength, we believe this presents, simply put, a new growth vector for not only Redis-based architectures, but also transaction-based workloads at large. And so if you use those existing cloud environments in new geographies that were previously unavailable to developers, we now have such a tremendous opportunity to take advantage of network performance characteristics like never before. And so by bringing your Redis data structures closer to the data source, and of course in turn closer to your end users, developers can finally rediscover the power of real-time data. Thanks again for the opportunity today. We're super excited to have had you join. And if you want to learn more about Verizon 5G Edge, check out our 5G Edge blog on Medium, go visit our developer resources page, or check us out on Twitter and LinkedIn. Thanks so much.